Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic: electric field due to line charge. Charge distribution. The charge can be distributed in terms of point charge, line charge, surface charge, or volume charge. In the case of point charge, the total charge is situated at a point. In case of line charge, the total charge is uniformly distributed over a line of length L with line charge density rho L. In case of surface charge, it is uniformly distributed over a surface with surface charge density rho S. In the case of volume charge, it is uniformly distributed over a volume V with volume charge density rho V. And the charge is equal to integral of dq. In case of line charge, it is rho L dl or dz. If the distribution is along z axis, then we can write dz. Electric field due to line charge. Consider the Cartesian coordinate system. X, y, and z. Consider a line charge. A charge is uniformly distributed over a line from point A to point B, and at point B we are supposed to calculate the electric field. We are supposed to calculate the electric field at point P due to line charge. For that, join the line BP, join the line AP, let it be the position of origin. Now draw a perpendicular line from the required point to the z-axis. Let it be some t. The coordinates of t are 0, 0, z, where z is the distance along z-axis. Consider a small differential element dl with coordinates 0, 0, z dash. Now let it be point P dash. Join the points P and P dash. The angle made by TP with respect to PP dash is alpha, and the angle made by TP with BP is alpha 2, and with AP is alpha 1. Now from the triangle PP dash T, tan alpha is equal to z minus z dash by gamma. Let it be equation number 1. and from this dz dash is equal to minus rho secant square alpha d alpha. Let it be equation number 2, and we considered the differential element at p dash, and the general equation for electric field is given by 1 by 4 pi epsilon q by r cube ar bar. It is a general equation. Now here in this case we are supposed to calculate the electric field due to line charge. So we have to consider the differential length, that is dq. Here the value of dq is equal to rho l dz dash by dq by r cube ar bar. Let us substitute the parameters later. Now what we require is the position vector ar bar. Always at what point we are going to calculate that point, we'll consider first. Here due to differential element dl, the differential electric field due to differential element dl, the differential electric field is dE, and to calculate the total electric field E, we are going to integrate uh, the electric field due to differential element. And here uh, our intention is to calculate the field at P, means the coordinates are, it is, let us assume it is position vector r1, it is r2. We are going to calculate the electric field at r1, means the position vector is simply r1 minus r2. This can be written as xax plus yay plus, here it is z and z dash, z minus z dash az cap. Let it be equation number 3, where the terms xax plus yay, already we know the value of rho is equal to x square plus y square. So this can be written as rho arrow cap plus z minus z dash az cap. It is ar bar. Let it be equation number 4, and now r square is equal to modulus of ar bar square is equal to rho square plus z minus z dash square from this equation. Let it be equation number 5, and from 1 and 5, from 1 and 5 we can write r cube is equal to rho cube plus secant cube alpha. Let it be equation number 6, and it is equation number 7. From equation number 7 we are going to start deriving the electric field due to line charge. Now here the electric field due to line charge E is equal to 1 by 4 pi epsilon naught dq rho l dz dash, that is dq is equal to rho l multiplied by dz dash, where the differential element is present at 0 comma 0 comma z dash position, dq by r cube. The r cube value is rho square plus z minus z dash square power 3 by 2 and once again it is multiplied by AR bar. Now this can be simplified as rho L by 4 pi epsilon naught integration rho hero cap plus z minus z dash az cap dz dash divided by rho square plus z minus z dash square power 3 by 2. Now once again we can simplify this. We can replace the value of dz dash. The value of dz dash is minus rho secant square alpha d alpha. Refer to the equations in previous slide. Now we can rearrange this as rho L by 4 pi epsilon naught. Here d alpha starts from, for the finite line charge, the angle of alpha starts from alpha 1 to alpha 2. Once again write the same thing, rho a rho plus z minus z dash az cap minus rho secant square alpha d alpha, once again divided by the same term rho square plus z minus z dash square power 3 by 2. Now we are going to replace the terms z minus z dash in terms of tan alpha and rho, and z minus z dash in terms of rho and tan alpha in the next slide. Now the equation becomes E is equal to rho L by 4 pi epsilon naught from alpha 1 to alpha 2 rho a rho cap plus z minus z dash can be replaced by rho tan alpha az cap divided by here rho square plus z minus z dash replaced by rho tan alpha square power 3 by 2 minus rho secant square alpha d alpha. Now we are going to divide tan alpha into sin alpha by cos alpha, and E is equal to rho L by 4 pi epsilon naught. Once again alpha 1 to alpha 2 minus, this minus will come this side, rho secant square alpha cos alpha a rho cap plus sin alpha az cap bracket close rho d alpha divided by the sin by cos the cost term will come in denominator, and by expanding this we get a rho cube secant cube alpha. And the next step is, uh, after simplification and rearrangement, we get rho L by 4 pi epsilon naught rho ranging from alpha 1 to alpha 2 cos alpha a rho cap plus sin alpha a z cap d alpha. And after applying the lower and upper limits, we'll get the E is equal to rho L by 4 pi epsilon naught rho minus of sin alpha to minus sin alpha 1. Substituting the limits plus cos alpha 2 minus cos alpha 1 az cap. Now this equation will give the electric field due to finite line charge. Now the electric field due to infinite line charge. For infinite line charge, the value of alpha is equal to plus pi by 2 and alpha 2 is equal to minus pi by 2. Substitute in the previous equation, we'll get the value of electric field due to infinite line charge is rho L by 2 pi epsilon naught rho a rho cap, where rho L is the line charge density, rho is the perpendicular distance from the required point to z-axis. Refer to the equation. Electric field intensity due to infinite line charge once again refer to the printed material. It is a position of 00z 00z dash. At this point we are supposed to calculate the electric field, and in this direction the position vector, it is the rho, once again alpha, alpha 2 and alpha 1. Here this term can be replaced by rho a rho cap. This is the equation to determine the electric field due to finite line charge, and it is the equation to determine electric field due to infinite line charge. Refer to the sample problem and its solution. Thank you. We will meet with the next lecture.